Well, now it's time for our final story of tonight, and we're going to talk about Saturn, believe it or not. Some interesting things been happening at this beautiful jewel of our solar system, my favorite planet besides Earth. Earth is my favorite. It's where I keep all my stuff. But Saturn's pretty great. These rings are gorgeous. And believe it or not, we didn't know how fast Saturn rotated. What's the actual spin rate of it? Sure, we could watch the clouds whiz around, but are they going faster than whatever's in spinning inside? And when we went by the first time, when we flew by, we measured a period of about 10 and a half hours. Well, we went back with Cassini, and suddenly we measured a period that was different. It was like 10.2 hours. And it changes, or I forget. I might have that backwards. Maybe it was 10.2, and then Cassini found it by a different time. And we thought, my gosh, could the entire ball of Saturn be changing? How would it's massive, it's huge. There's no way it could change the rate it's spinning. So they needed to figure out what was happening. Well, the Keck telescopes were just recently used to measure a speed of some aurorae. They figured that they were measuring the spin rate before by noticing when a repeating radio burst would come by. And they thought that was caused by the inside of the planet. Well, then they learned a little bit more about it and said, these radio bursts might be coming from the aurorae. That's right, that blue glow up at the top of Saturn. They thought maybe there's something in there that's causing that radio burst. And if you change the rate the aurora is spinning around, you might change the rate of those radio bursts. And they thought that might be what's happening. So indeed, they used the Keck telescope to measure the speeds of the winds up in the ionosphere, the very upper region of Saturn. And the prediction was that in order to make this happen, you'd need to have two cyclones. You can see there's two centers of spin up there working together to funnel that material through the center, accelerate it quickly, and actually activate the aurora being created by these high-speed winds. So it's another mechanism to make some aurorae. Now, the aurorae are happening in the infrared part of the spectrum, but notice that arrow is changing directions. Sometimes the wind's coming at us, as it's about to now, and sometimes the wind's going across, and sometimes it's going away from us. And that actually, if this was correct, was how the spin rate of Saturn was being not really influenced, but we were being tricked into thinking the speed was going at different rates based upon this. And indeed, they were able to see that, and they detected evidence for these two cyclones up at the top of Saturn. So a really remarkable finding that they used with the Keck telescope. Now you might think, is this related to the hexagon? You've heard about the hexagon on Saturn. Indeed, you can see those clouds down there. Actually, no. Those are created by storms that are stable in the lower part of the atmosphere. And in fact, the storms look a lot like those storms at Jupiter. This is the picture of Jupiter here that Patrick was talking about. And you can see that stable configuration of 5 storms with one in the middle between February 2017 all the way to October 2021. And they're still there doing their thing. So those storms have nothing to do with these ones that are higher up that are causing these aurorae. The ones that are higher up are up above that haze layer you can see there. They're up in the ionosphere, well above the clouds we're seeing. So the two phenomena are not directly related at all, other than the fact that they are sort of circulations in winds that create them both. But the ones that they measured with this, the aurorae on Saturn, were a little different. And here's another picture, a beautiful picture of the Saturn aurorae that you can see down at the bottom of Saturn here in this really cool infrared glowing image.